you're prohibited from studying. Um, we took a look at academic classicism back at the very beginning of the semester, and we looked at it as the legacy of Renaissance architecture that was perpetuated and that continued well into the 20th century. And while it was a design style, if we can call it that, it was also an educational system. And we know that there were a lot of American architects from the middle of the 19th century well into the 20th century who were educated in the academic system of classical design. And we also identified some of the basic principles behind academic classicism: central axis, symmetry about the axis, tripartite design, use of the architectural orders, typology, etc., etc. And of course, the great example that we took a look at was the Paris Opera House. Now, if we take a look at the plan of the Paris Opera House and compare it with this plan, we're going to see that there is a lot that these two have in common. In both cases, there is a central axis and a cross axis. There's a use of basic geometry in the layout of the building. We'd have to come in and analyze it better, but there's a great attention to the circulation pattern in both of these buildings. And right in the center of both of these buildings, where the axis and the cross axis come together, we've got theater space. Yet, if we take a look at the outside of these two buildings, we're going to see that they couldn't be further apart. Whereas the Paris Opera House has historical forms and a lot of very florid detail, the other building that we've been looking at has neither of those. Yet, it still has a central axis, it still has symmetry about the axis, and there's still a use of basic geometry in the organization of the building. So, while these are different in many ways, they're similar in a lot of ways as well. The building that we've been taking a look at on the right is the National Assembly building in Dhaka, Bangladesh, that Louis Kahn designed. And this is going to give us some insight into the ways that he developed upon international modernism. And obviously, there's going to be a very strong classical background to it, even if it doesn't look like a classical building at first. Louis Kahn was one of the preeminent architects of the 1960s and one of the greatest American architects. And his works showed how architecture could be modern, but could also be expressive and monumental and appealing in ways that a lot of modernist design was not considered to be appealing or monumental or even expressive at the time. Kahn was born in Tsarist Russia on an island that is today part of Estonia to a Jewish family that was relatively well integrated into Russian society. His mother's family were prosperous landowners and farmers. His father was in the Russian military, and so pretty well integrated. But during some of the anti-Jewish efforts of the Tsarist regime, the family began to experience difficulties. Kahn was a young baby when his mother's family lost the family farm because it was confiscated, and the Kahns decided that they needed to emigrate. And so they went to the United States, basically with the clothes on their back, landed in Philadelphia, and had quite a few years of some pretty dire circumstances economically. There was one year in which the family had to move multiple times, more than a dozen times, because they couldn't pay the rent. And so they kept on bouncing from apartment to apartment to apartment. When Kahn was in school, the family was too poor to afford drawing materials for him. And so his father used to collect sticks and go out and get clay and make his own charcoal in the stove that was used to heat the apartment that they lived in at the time. Yet Kahn excelled in some things in school, certainly in his drawing classes, and he used to supplement the family income by doing drawings that he would then sell. Um, and he came to the attention of some of his high school teachers who promoted him to the admissions committee at the University of Pennsylvania, and he was admitted to the architecture program at the University of Pennsylvania. At the time, in the 1920s, the educational system at the University of Pennsylvania was academic classicism. It was modeled after the École's education in Paris. And so Kahn was schooled in architectural design by learning the architectural orders, by learning how to compose with the basic classical principles, by using typology in the buildings. So he was a fully formed classical designer when he graduated. Yet he was aware that there was a new sort of architecture coming out of Western Europe. And it wasn't long before he began to emulate what he saw coming out of Europe. Here we're taking a look at a house that Kahn designed pretty early in his career in the Philadelphia area. And if we really take a look at the forms, the materials, the way that interior spaces are distinguished one from the other, we're going to see a very strong influence of Aalto in some of these things, using a variety of materials, sometimes modern, and in this case, materials that we wouldn't consider modern materials, all as a way of enlivening the design. Not creating separate interior areas with walls, but rather using the flooring pattern to distinguish the different areas of the house. A whole variety of ways in which this really speaks about Aalto's influence on Kahn. Kahn continued with his modernist designs and supplemented his architectural practice with taking on different teaching positions at Yale mostly, but also at the University of Pennsylvania. And it seems that his interaction with the students was really something that enlivened him. It seems that the way that he could have an intellectual and highly philosophical discussion with the students, all as a way of advancing their design processes, was something that he just absolutely enjoyed. And so he's going to continue as an educator throughout much of his career. And a lot of his thoughts have come down to us because of the lectures that he gave, those lectures which were transcribed, or lectures that he later turned into essays and publications. But we really get a sense of what his thoughts were because of the way that he communicated them with words, whether oral words or the written word. Midway through his career, Kahn was awarded the Rome Prize at the American Academy of Rome. And the American Academy of Rome was one of the great institutions founded in support of academic classicism in the United States. It had the idea that both students and practitioners would benefit from going to Rome and spending an extended time of a fellowship at the American Academy, where they could experience firsthand the art and architecture of Rome. Kahn applied, he was accepted, he went to Rome for an extended period of time, and while he was there, he certainly had the chance to see the buildings that he studied while a student at the University of Pennsylvania, buildings that he saw on previous trips to Italy. But on this time, there was also something else that really caught his imagination, and that was the ruins of ancient architecture, not the beautiful Baroque palaces, not the Renaissance churches, not buildings that had been adaptively reused, but buildings that were still the ruins. Somehow they seemed to have a force and a power to them that captivated him. And when he came back to the United States, his designs changed significantly. One of the first buildings that we can take a look at that shows something about this newfound direction to his design is the Yale University Art Gallery. Now, once again, this is not on the monuments list. I know that there's one or two of you who is actually studying this for your research paper, and that's perfectly fine. Um, but I'm going to look at this as sort of the first indication of where Kahn is going to go with his mature career following his time at the American Academy in Rome. The project was for an addition onto the University Art Gallery, which was a pre-existing building. And in the image up to the upper right, you can see the pre-existing building to the right, something that obviously that's based on historical examples. And Kahn's addition just extended that further back on the site. If we take a look at it in section, we can see the way that he took his cues from the pre-existing building, where the floor to ceiling heights in the main gallery spaces are carried through Kahn's addition, which is to the left in that section. And the height of those spaces was so generous that he was able to divide that into 2 floors. And so we've got 4 floors of fairly tightly packed spaces, but still 4 floors with large, generous floor areas, even if the ceilings were relatively low. One of the things that's very interesting about Kahn's addition here is the structural system. If you take a look at the plan, you're going to see that it's a point load system, and the material was poured-in-place reinforced concrete for the structural supports. But spanning between those structural supports, there are beams connecting these different structural supports vertically in the plan that we're taking a look at. But there was also a structural system that spanned between those different beams and the different structural supports. And that structural system was composed of poured-in-place reinforced concrete, but it was this very complicated geometry that is sort of a combination of a pyramidal form, but a pyramid that is triangular in plan and that rises up with 2 of the sides being open, only sort of defining structure along the axes that define any of those triangles. But then there is this continuous angled panel which connects them, and that runs continuously. A very interesting combination of different forms, some of them reduced down to lines, some of them being more of an angled plane. But this was going to be structure as well as location for the utilities. If you take a look at the sort of cutaway axon that we have up in the upper right image, you'll see that the openings that were left in the triangles provide space for different utilities to be fed through. And if we look up into those spaces, we can see those utilities, including the lighting system and obviously the electricity that feeds the lighting system. This was a structural system that was developed in Kahn's office. It was always attributed to Kahn. Recently, there's been some question about whether it was Kahn himself or Kahn in collaboration with his associate Anne Ting, or whether it was really Anne Ting and Kahn just used it in the design. At this point, we still don't know, but perhaps we can think of it as a collaboration to some degree between Kahn and Ting. And this is what they came up with. And the effect that this had on the space was going to be really pretty interesting. When we take a look at the gallery spaces, and when we see the repeated geometry of the ceiling here, it seems to recall some of the coffering that we might see in ancient Roman concrete architecture. Coffering such as in the Pantheon or in the apse of the Temple of Venus in Rome, which is in Rome. It seems to be heavy and weighty. It is not the lightweight, abstract use of materials that we would see in international modernism. It seems to be something much more, well, concrete as an adjective, but something that that's just very different from some of the radicalized modernism that we saw earlier. Uh, Throughout the composition, Kahn is interested in geometry and light and concrete and designing these really wonderful spaces and this really powerful combination of geometric forms. So when we take a look at Kahn, um, yeah, we need to appreciate the new direction that he's taking after his time in Rome. But there are some fundamental things that are going to run through many of his projects. First of all, we need to acknowledge his Beaux-Arts training. Yes, he moved away from it for a number of years in the 1930s, 1940s, but following his time in Rome, he comes back to it in some surprising ways. Obviously, his buildings don't look like they're classical buildings in the lack of ornamentation and decoration, but in the basic principles, they seem very much to be classical buildings. In the assembly building in Dhaka in Bangladesh, we see in the center theater space that is typological, right? It draws upon that notion of plan types from ancient Roman architecture and also from Renaissance and Baroque architecture. Now, if we were to go back to the origins of a building type that would serve representative government, specifically the Bouleuterian, we can see two images on the right, the remains of a Bouleuterian and then a hypothetical reconstruction of what the space was like. Not exactly theater space, but so we've got bank seating on three different sides, all of which is facing the lower rectangular floor space of the building. Kahn is certainly versed in this, and we see him picking up on it and reinterpreting it, and also taking a look at the long legacy of this sort of architecture for representative governments. One important example was undoubtedly going to be the national Capitol in Washington. And here we can see theater seating for both houses of Congress, the Senate and the House. And we see a dome that is over ceremonial space, dome that's over the rotunda here. But bringing domes and democratic or buildings for democracies together certainly is important in the example in Washington. But if we take a look at the Parliament building in Dublin, in the two images on the right, we can once again see theater-like seating and a dome-like covering over it, bringing them together, right? And that seems to be what was inspiring Kahn for that central space in the government building in Bangladesh. Theater seating, and initially he wasn't going to put a dome over it. He was going to sort of rethink what was possible using port-in-place reinforced concrete. And eventually he's going to come to something that is a little more dome-like, but still something that has a strong geometry to it and allows light in some interesting ways, but really seems to be his own reinterpretation of the use of the dome for democratic governments. And so we see him with his Beaux-Arts training taking it in a slightly different direction. He had a design process that would start by focusing on the social aspects of any program, and would then lead to what he would call a form drawing or form diagram. Now here we're taking a look at a number of diagrams that he put together for a commission that he had, specifically the Unitarian Church in Rochester, New York. In talking to the congregation, he realized that what really brought the people together was not necessarily long-standing family tradition, was not necessarily rituals and ceremonies, but the thing that seemed to bring people together to the Unitarian Church were questions and looking for answers. And he realized that that the building needed to be composed not only of worship space, but also of other spaces, multi-use spaces that could be used for social or educational purposes. And so he began examining the ways in which these things could come together based upon his discussion with the people in the congregation, right? How was it that they came together, right? How can that social aspect of this program be brought to the fore? And after discussion, thinking, right, moving ahead with the design, all of a sudden there is this intuitive leap to form. It isn't a rational process. It's not something that you can chart out step by step. It's not something really that you could even teach. It's just that by working and reworking these different form drawings, all of a sudden, boom, there's this leap to form, and he understands what the building needs to look like. His goal is to come up with a form that's going to house the program, but also represent the program. And so if we take a look at the final product, we can see the central worship space for the Unitarian Church. We can see a walkway that surrounds that worship space. And then we can see all of the other spaces, the social spaces, the educational spaces, the support spaces that wrap around that sanctuary. Yet it's in the structural system that he designed for the sanctuary where we can see the leap to form, right? Something that, again, houses what's going on here, but also represents it. Kahn believed that it was the role of the architect to be a form giver. The architect had to determine the form that was appropriate for the social aspects of the program and to give that to the people. And when he did that, his preferred way of looking at this was that he was designing monuments for institutions. Now, we may think that institutions are some cold bureaucracies, but he didn't see it that way. He thought any institution represented the highest aspirations of humanity. And so the city government, he didn't see it as a bureaucracy. He saw it as people coming together to try to live well. A university, he didn't see it as, some sort of money in, degree out machine. He thought that this was the place where people came to pursue learning and ideas. And he wanted to design monuments for these institutions. He wanted the buildings to be monumental. And that notion of the architect as form giver and that intuitive leap to form was what would give him the monuments for these institutions. Kahn also believed that in order for a space to be architectural space, you needed to have natural light. The variation in the quality of the light over the course of the day, as well as the direction of light over the course of the day, is going to enliven space and turn it into something that was truly architectural. In Kahn's architecture, we can see an expressive use of materials. Reinforced concrete was one of his favorite materials from his mature architectural practice, but there were others as well. And here in this atrium that he designed for a library, we can see the way that he brought light into the space, but we can also see a use of reinforced concrete that is not hidden from view. It's out there, and it is, in a way, talking about the arcuated form and structure of load-bearing, massive, compressive materials. And on the exterior of this building, we see a different material, brick, where there appear to be 4 different facades that have been sort of lightly separated from the core. And if we take a look at the details here, specifically those flat arches that create the openings at each floor level, we see him using the material tectonically. Right? What is the capability of this material, and how can it be used here in the overall building? The first complex that we're going to take a look at that Kahn designed, probably not the most evocative in terms of those monuments for institutions, but still an important project to show what his capabilities were, and also as a send-up for the next one, which is going to be the Salk Institute. These are the Richards Medical Research Labs at the University of Pennsylvania. And these buildings, these towers, were intended to be large open lab spaces where the space itself was wide open and flexible, and where the utilities would be they'd be able to reconfigure the utilities and how the utilities enter these spaces in order to support the different projects that were underway, the different experiments that were underway in these labs. If you think about setting up a lab for a particular experiment, you might imagine the step-by-step process that the experiment needs to take, and that the furniture within the lab is going to be organized in order to facilitate going from step 1 to step 2 to step 3, etc. You might also imagine that the utilities, the gas supply, the water, the drain, the air handling needs to be flexible so that, at least to a degree, you can accommodate that reconfiguration of these labs for each of the experiments. And that's something that Kahn was interested in doing here. When you look at the plan, you can certainly see the repeated forms of those square floor areas, and in the middle of each of those floor areas, you can see that there is some secondary space connected to those floor areas. Now, if we take a look at the exterior, we can see that those secondary spaces are actually these brick vertical elements. As a point of departure for this building, Kahn divided served spaces from servant spaces. The served spaces were obviously going to be the labs, right? The servant spaces were going to be those vertical towers, which could provide egress for people. They were fire escapes, but they also would be utility chases that would feed the air handling units, the plumbing, the electricity, the gas vertically, which would then be fed into the building in a variety of ways. So we can see the division of the program into served spaces and servant spaces. And servant spaces has a very distinctive form to it, right? Those vertical brick towers. The served spaces, on the other hand, used a different material and a different structural system. The structural supports for the lab floors are going to be reinforced concrete piers, and then the floors of the labs are going to be supported on joists of reinforced concrete. But those joists were not poured in place reinforced concrete. Rather, we see new technology that Kahn is going to adopt and use here in an innovative way. Each of the individual structural elements here are reinforced concrete, okay? Each of those horizontal joists, which you can see hanging off the end of the crane up there. Yet they are all, first of all, precast. Precast meaning that they were formed elsewhere and then shipped to the site. They were also pre-stressed, which means that there were tension rods which were affixed to the formwork for these, and then those tension rods are pulled taut. And so the formwork deflects a little bit in order to accept that tension, and the concrete that is poured in ends up taking the geometry of that tension, the geometry as a result of the tension rods. Okay, so they're pre-stressed, and then once they're at the site, they're post-tensioned, which means that all of those reinforcing rods, whether they're running the length of the particular joist or whether they've been fed through horizontally, are all going to get connected and pulled taut into a system that expands in 2 dimensions and that forms the joist system that supports the floor, which is going to be above. So precast, pre-stressed, post-tensioned into a system. A couple of things that were innovative about this. Other engineers had used this system before, but from what I understand, nobody had used it on a multi-story building. And so we see Kahn taking the technology and using it differently, right? Using it in a multi-story building. Furthermore, when we take a look at the structural supports here, we see that the structural supports are down each side of the square lab floor, but at third points. What does that mean? Well, that means that there is no structural support right at the corner. And so the structure that cantilevers out to the corner, as any cantilever would, doesn't need as much material to the outside extent. And so what we see Kahn doing here is innovating the structural system to diminish the amount of material at that outside cantilevered corner, thereby lightening the load, but also expressing how the loads are being resolved within the structural system. And so the building ends up having this very interesting corner detail that shows Kahn's understanding of the structural system and shows how it could be manipulated to be expressive structure as well. The complex was very interesting, and architects immediately loved it. The scientists who worked here, not so much. They found that the large amount of glass brought in many cases, too much light, and there was a lot of thermal heat gain in the summer. Furthermore, the spaces were too bright, and so many of them had to adapt by hanging sheets of paper on the glass windows. And furthermore, they wanted office space close to the labs. And so they had to sort of rig these offices around the perimeter of these of many of these floors so that there would be close proximity between the office and the lab. So it seems that there were a few things that Kahn didn't quite think through here. But nevertheless, in terms of the architecture, it's a very interesting complex. And it's also one that led into his next commission, his next Great Commission. Here we're taking a look at a picture of Lou Kahn on the left and Jonas Salk on the right. Jonas Salk was the scientist who discovered the vaccine for the polio virus. Polio today isn't a real concern for Americans because most of us have been vaccinated against polio. But before the vaccination, especially in the late 1800s and in through the middle of the 1900s, polio was a very serious health threat. It was possible to catch polio and to end up partially paralyzed, like Franklin Delano Roosevelt had been, or even to lose your life if the virus attacks some of the central nervous system and some of the vital organs. But Salk discovered the vaccine for that, and not surprisingly, became a very wealthy man. And he decided that he was interested in founding a research institution for scientists, but a research institution with a twist. He was interested in bringing diverse scientists together and give them the opportunity to have social interaction, with the idea that one scientist's experiment might open doors unexpectedly for scientists doing other experiments in other disciplines. So his idea was if we get some sort of cross-fertilization between these disciplines and these scientists, and if we do it in a social way, then perhaps there are going to be breakthroughs in the sciences that are unexpected. Now, given the social component of this and the fact that this foundation was going to be in its own way an institution, you can imagine that Kahn was all over this project. Salk was looking for an architect. He had heard about what Kahn had just completed in Philadelphia. He went to take a look at the labs. The two men met, and there was a meeting of the minds. And after that, Kahn received the commission, and he designed the Salk Institute. If we take a look at an aerial view of the Salk Institute, we're going to see the site that this is on. And it's in a location in La Jolla, California, just a little to the north of San Diego. Now, if we take a look at this view, to the right, you can see the north-south roadway that defines the eastern edge of the site. And then from the roadway going to the left, or going west, or heading out towards the Pacific, it's fairly flat up to a point. And then it begins to get rolling, the terrain, and eventually it becomes quite rough before there is this escarpment that just all of a sudden drops down to the beach. And then we've got that strip of beach, and then the Pacific, and then water for as far as the eyes can see. And so this was the site that Salk obtained, and this was the site where Kahn was going to design a number of different buildings. The building that we're going to take a look at are the research labs, which in this plan are the ones that are further to the right. But you'll note that there are two other complexes here as well. There is the housing complex, which is down in the lower left, something that was planned, but as far as I know, was never actually completed. And then we've got a conference center, which is up in the upper left. And Kahn had designed the conference center to at least some degree, but as far as I know, it was never built in its location. Rather, during Kahn's lifetime, it was only the research labs, again, the part that is furthest to the right in the plan, that was built. Now, if we take a look at where it's located on the site and how the site is developed, you'll see that closest to the roadway, we've got these parking spaces. Right? And so however you're getting here, right, coming up and down the highway, you're going to park your car. And then you have to walk across this green field with this informal planting of trees to approach the complex itself. And when you take a look at the complex in plan down below, we're going to see that they are two parallel but mirror imaged lab complexes that are organized on either side of this horizontal, longitudinal social space, right? This courtyard that runs between the two. It may be a little difficult to pick out in the plan, but as we go through, you're going to get a better sense of how the building actually runs down both long sides of that courtyard. Excuse me. Now, if we were to take a look at a section through the lab space, and that red line there shows a section cut that may correspond pretty closely to the building section that we're taking a look at there. You're going to see that there are alternating floor levels. One floor level that has one height, and then another that is a bit shorter and that has those vertical piers in it. What we're taking a look at here is alternating floor level and structural level. Floor level, structural level, floor level, structural level. Once again, Kahn is thinking in terms of served spaces and servant spaces. And in this particular case, the served spaces are going to be those floors, and the servant spaces are going to be in those structural joists that span the width of these different lab spaces. So the utilities are going to rise vertically through these tower-like forms that are on the outside edge of the site. And perhaps you can locate those in plan, and in the section perspective, they're off to the left. And then the utilities would be fed through those floor levels that correspond to the structure, and then from there down to the lab below, or up through the floor to the lab above. You'll also note in taking a look at this section that the lowest floor level is actually below grade. If you take a look at both edges of that section perspective, you might be able to make out where the grade is on both of these. And so Kahn excavated down and gave basically a 3-story building with those structural floors in between, but the lowest floor is going to be below grade. There are large light wells to the perimeter, and if we go to the right of that section, we're going to see something else that's very interesting, this light well, and then we're going to see these building parts that actually line the courtyard. But the occupied spaces here alternate with the floor levels in the labs. And so if you can imagine being in the middle lab floor there, looking out sheet glass windows across that opening, you'd be looking under the enclosed space out to the courtyard. And then corresponding to that enclosed space, you would see the structural floor. So it's sort of this alternating occupation. And those spaces that are out closest to the court are going to be offices. Here we're taking a look at the perimeter where we can see those vertical servant towers that feed into the enclosed spaces of the structural floors. And we can also see those horizontal strips of sheet glass which are providing light into the inhabitable floors of the labs. And here we're taking a look at a view from the courtyard down into the light well, which provides light to the lowest level, as well as those alternating floors of office spaces for the different scientists and the assistants who work here. The perimeter of the building is certainly looks fortified, right? It certainly looks like it's completely enclosed. And the courtyard that we have here in the building is a really beautiful, highly directional space. Originally, Kahn had some very clear ideas about what he wanted to be in the space between these parallel lab buildings. And initially, he thought garden. Garden made sense to him because when you read ancient Greek philosophy, you realize that a lot of the education took place under trees in gardens. Philosophers would gather people interested in discussing things and their pupils together under the trees, and that's where they learned. And so Kahn felt that that was a great model for this space. And he also knew exactly who he wanted to design that garden, and it was Barragan. And he reached out to Barragan. He offered him the commission. Barragan was interested in discussing it. Barragan spoke to him about what his goals were. And as Barragan listened to what he had to say, Barragan convinced him that he didn't want this to be a garden, but rather he should think of it as a plaza, social civic space. And so based on Barragan's suggestion, Kahn ends up paving this and gives it a water feature like you might find in a plaza. The material that he uses as the paving here is travertine, which once again is a rough sort of marble that is found around the city of Rome and that was quarried as the finished material for a lot of the ancient Roman buildings and was also used as a finished material for a lot of the Baroque and Renaissance buildings. So a material that has very strong classical allusions to it. And if we take a look at the water feature that Kahn designed, a little source, but then this channel that runs right down the center of the plaza, and it appears to fall off the edge of the plaza, but actually descends in through a number of scuppers and pools down to a retaining pond at the lower level, quite out of view, but a lower terrace, and here you can see the rough terrain as well as the Pacific and the horizon line beyond. But what's interesting is what you perceive when you're in the courtyard. And what you perceive is some connection between a single source and something that seems infinite. And it's a very powerful experience. And when you really take a look at how highly philosophical Kahn was, I don't think it's possible to over-intellectualize some of the things that he did. Now, my theory is that Kahn was trying to say something here about the work that the scientists were doing in the labs. If you think about scientific experiments, they're trying to unlock one particular little element of the universe. They're trying to understand how one little thing works in a much larger system. And like that connection between the finite and the infinite, so here too we see this connection between a very finite source of water that appears to connect with the infinite ocean beyond. Just a theory, but it seems to me that there's a very powerful message that Kahn is trying to communicate here with the water feature. At the end of the building, at the end of both of those lab spaces, again, we're going to see more office spaces that overlook the rough terrain and the ocean beyond. When we take a look at the materials that Kahn used, we can see a very limited palette, but a very interesting palette. The structure of the buildings is going to be poured in place reinforced concrete. Within the openings, he's either going to have sheet glass or teak wood. And teak is a particularly good wood for this location because it is resistant to damp and to wet. And given that this is right on the coast and there are often coastal fogs that come in, you can understand that that might be a good material to use. Today, we need to be very careful about where teak comes from, because if it's not sustainably harvested, then it might be coming from logging operations that are being detrimental to some of the tropical rainforests. But in any case, in Kahn's day, they weren't thinking about that. I don't know exactly where this teak came from, but he has that material here. And Kahn paid a lot of attention to the craft of making and how the material could be expressive of that making. Poured in place reinforced concrete is obviously going to use some sort of formwork. And if you think about the parallel walls that you need in order to support the concrete that's being poured into the formwork, you can imagine that there's going to be a lot of structural support that's needed for those walls. And you can go about that in a couple of different ways. On the one hand, you can build up a lot of structure on the outside of the formwork to stop the concrete from sort of pushing the formwork out. Or what they also discovered is that with some framework, you can connect both sides of the formwork with tension rods. And so the way that became common for building reinforced concrete walls was to build framework with plywood slabs to the inside of both of those parallel walls. And then you would run tension rods from one piece of lumber on one side of the formwork to a piece of lumber on the other side of the formwork. You would secure those tension rods, and in that way, when the concrete was dumped in and when the pressure built and when the concrete was trying to push the formwork out, that pressure would be counteracted by the tension rods. And so that's what Kahn did. Obviously, at the end of the pour, you need to pull once the concrete is cured, you'd pull off the formwork, and you'd pull the tension rods out of the concrete, which would leave a hole. And usually what they would do is they would send somebody around with a spatula and some wet concrete and kind of try to fill in the hole with wet concrete. Kahn had some different ideas. First of all, if you take a look at these wall surfaces, you can see that there is a repeated geometry here that doesn't exactly correspond to the 4x8 panel of a plywood sheet. Rather, Kahn had the plywood cut into smaller panels, and furthermore, the cuts were angled so that the indentation in the formwork would turn into a protrusion in the concrete wall, because the wet concrete would go and would occupy the indentation in the formwork, and when you remove the formwork, it would turn into a protrusion, and so you begin to get these different regulating lines through the wall itself. And furthermore, you had those tension rods and the holes of the tension rods, the holes left by the tension rods. Kahn didn't want somebody going and trying to make them go away. Rather, he designed a metal cap that was then inserted into all of those holes so that you still see the holes, you know where they are, but they're plugged so that water ideally will not get in and can't make any contact with the reinforcing rods and thereby damage the structure. What we're left with is a very interesting use of the material and a design of the material that really is a design of the process of making the material, where you can still see it on the exterior of the building. This is one of Kahn's great monuments, and it shows monumental architecture for an institution, and specifically for the social aspects of that institution. Today there have been some additions that were put on. In this view here, you can see Kahn's labs to the lower left, and you can see how these additions were sunken into the site, were added symmetrically between the road and Kahn's buildings. As the institution grew and developed and as they needed more spaces, this seemed to be the best solution. Pretty interesting solution in many ways, but certainly not competing and intending not to compete with what it was that Kahn accomplished in his building. The last building that we're going to take a look at is a building that I think many of you have had the opportunity to visit, and it is the Kimball Art Museum up in Fort Worth. And here we can see Kahn designing a structural unit that he repeats a number of times down the length and across the width of the entire complex. These repeated vault-like concrete structures, and the way that they're repeated here seems to call to mind some ancient Roman buildings that we're taking a look at in the images on the left, which were warehouses, multi-story, barrel-vaulted concrete spaces, certainly fireproof, certainly long-lasting, but just these parallel and pretty tightly packed barrel vaults in concrete, and the complexes were known as Horea. Could be a source for what Kahn was doing, but when we think about what the Horea were there for, again, these are warehouses, and when we think about what the curators at a museum hope to do, the curators at a museum don't just want to warehouse the art. They want people to come in and to enjoy it, to be edified by it, to be inspired by it. They don't just want it to serve as a warehouse. So I'm not so sure that a Horea is really the best example that we can take a look at in order to understand what Kahn was doing. But if we take a look at French palatial residential architecture from the 16th, 17th, and 18th centuries, we're going to see a building component, specifically the gallery, that seems to be a pretty good fit for those individual structural units that Kahn designed. In these images, we're looking at the interior of the Galerie des Glaces at the Palace of Versailles, and in the plan of the Palais de Luxembourg in Paris. If we look at those two parallel wings that extend out away from the residential part of the building, we would see gallery spaces. Galleries were often longitudinal, often barrel-vaulted spaces that had art permanently affixed in them, and it was a combination social space and also space to display art. And this seems to be a perfect fit for at least one of those units, the individual units that Kahn had designed for the museum. These are made of port-in-place reinforced concrete. They consist of piers at the four corners of each of these units, horizontal beams that run down the length of these units, supported by the piers, obviously. And then on top, we've got something that is a little bit, it's not exactly hemispherical, it's a little depressed, right? It doesn't rise quite to the height of a hemispherical vault. And furthermore, is not a structural vault. A structural vault is going to have each and every part of it in compression. And what we have here instead is thin shell concrete construction, which means that it's a combination of concrete and reinforcing mesh that is poured thinly onto molds that were movable. And so the molds would start at one end, would support the concrete while it cured, and then would move down a little bit further and a little bit further until finally the entire structure here was covered. What this means is that there is a seam down the middle of each of these thin shell coverings that can get opened, and we're going to see what Kahn did with that possibility when we get to the interior of the space. The way that he articulated all of these different port-in-place reinforced concrete elements allows us to see a pretty clear base to the whole building, a base to the pier, a capital to the pier. We see the way that things interlock and sort of connect one to the other. But he's separating them all out. So there is a bit of distance between each of these units, both in the both lengthwise and in the short dimension, right? So we can see that there are gaps, and those gaps are going to provide some very interesting opportunities. Within the structural system, we've got these travertine slabs of revetment, again, travertine, that Roman marble that is used to actually enclose some of the spaces. In the plan, if you take a look, you can see the different units that he lined up end to end and side by side down the length and the width of the site. Now, if you go there today, chances are you're going to park in the parking lot, which is located across the street behind the Salk Institute, and you're going to walk across the street and go down a service drive and enter at a lower level, which you're taking a look at in the image on the lower left. And then from there, you're going to have to find your way to a staircase that'll bring you up to the main level, and then from there you can move around. That's the way that many people approach the building and enter into the building. But that's not the way that Khan wanted you to enter into the building. He wanted you to first walk across this grassy lawn and then walk through trees. And the reason that he wanted you to do that was because he had enough experience of the Dallas-Fort Worth area to know that you're going to be spending a lot of time in cars and a lot of time driving. And so he wanted people to be able to get out of their cars and to walk through green space before approaching the museum. And the green space could be grass, it could be an informal planting of trees, but he created the entrance to the museum by removing a couple of the units right in the center, right? Creating this axial organization that is actually on the cross axis of any of these individual units. And within the gap, within that void where he removed two of those longitudinal units, he had a planting of trees on a grid system. So you go from green space that is open to green space that is canopied but informal, to green space that is canopied but more formal, and then into the building itself. And when you enter into the building, it's interesting how he's creating points of interest by removing sections of the entire system. He removes sections to allow this drop down that you can see here to lower level gallery space. He removes sections to create skylit, well, actually open air, little courtyards that are sculpture courts, or an open air courtyard which serves the cafe, which in the plan that you're taking a look at there is over all the way over on the left. When you enter into the building, you really begin to notice the voids. And the voids are opportunities for Khan. It's opportunities to bring light in that is going to be dramatic. Here we're taking a look at some not fully enclosed units and how that separation allows light to come in. But also note that at the very top of the travertine end wall there, and below the underside of the thin shell concrete covering, that there's a gap that's been filled in with glass. And again, an opportunity, that void, to bring light into the building. What's really beautiful about this is the way that he controlled the hot Texas sunlight from coming into the building. Wanting natural light, but also realizing that he needed to control the heat and the damaging rays of the sun, he took advantage of that seam in the thin shell concrete covering. And for the gallery spaces, he opened it up, designed a reflector of metal and perforated metal panels, and allowed the sunlight to be reflected up onto the underside of that vault light covering so that it could wash down in a cool gray light in the interior space. When you enter on the cross axis, but you don't go very far before you sort of rotate to the right or the left and find yourself going down the length of some of these units in order to access the gallery space. And then from there, you kind of slide from one of these spaces to the next, going under the gap between one of these vault-like coverings and the other. And again, he's taking advantage of it. This is transitional space, but this is also a place to feed some of the utilities through. And so a lot of the air handling and the lighting and the electrical is in that ceiling that is between these vault-like units. Some of the spaces, some of the secondary spaces seem to fit well within this. If we take a look at that upper level library space, you can see that it fits well. Other things seem to be a bit jammed in, such as this auditorium space, but still a very strong element, a very strong spatial unit that is given a variety of different experiences as you enter into and move through the building. And a lot of attention to other materials and the way that the building is going to be finished out. So once again, Kahn paying attention to an institution and designing a monument for that institution. If you go there today, you see that the site has been altered somewhat from what it had been. You still have this grassy area, but the grassy area has a correspondent on the other side of the grassy area from Kahn's building. And this is a new museum that was designed by one of the great museum designers, Renzo Piano. So certainly laid out and considered to be an homage to Kahn, but also something that's significantly different. So we look at Kahn as somebody who gave us a monumental sort of modern architecture, who showed us one particular way in which modern architecture can have a relationship with history, for however paradoxical that is. But also something that is specifically for the social aspects of institutions, which is what he enjoyed designing for.